So we're going to look at a mixture of exam questions on the topic of similar area and similar volume. To get from a scale factor for length to a scale factor for area, we square. To get from a scale factor for length to scale factor for volume, we cube. To get back from area to length, we square root. And to get back from volume to length, we cube root. You can't do anything to get from a scale factor area to scale factor for volume. You've got to always go back to length. Okay, so IGCSE and Excel do like these ratio questions. A and B are mathematically similar. Height of A to the height of B is in the ratio 3 to 5. So for a length, let's say we had a length of 3 on A, it would be 5 on B. Find the surface area of A to the surface area of B and the volume of A to the volume of B. So we can use that 3 to 5 to get a scale factor for length, because heights are length. So the scale factor for length would be 5 over 3, which I'm just going to leave as a fraction, because if we divide, we get a recurring decimal, it's more accurate as a fraction. How do we get a scale factor for length? We square. Nope, area, sorry. We square our scale factor for length. And if we square 5 over 3, again, I'm going to leave it as a fraction, we get 25 over 9. So the ratio of area A to surface area B would be 9 to 25. And similarly, to get the scale factor for volume, we need to cube the 5 over 3. (125 over 27). So the ratio would be 27 to 125. Okay, have a go at these two questions. Put me on pause and unpause to see how you've got on. Now, C and D are similar. The length of C to the length of D is in the ratio 9 to 2. So what's our scale factor for length? I always do the bigger divided by the smaller. 9 over 2, 4.5. We want the surface area of C to the surface area of D. So let's square our scale factor for area. We get, it's going to be best left as a fraction, so we can actually then write it as a ratio. If you've got it as a decimal, it's not as easy. And we see you've got 4 to 375, but we've got the bigger to the smaller. So it would be 375 to 4. And then scale factor for volume, I'm going to leave it as my fraction and cube it. So I'd have 2 cubed on the bottom, which is 8, and 9 cubed, which is 729. Let me just see if I can simplify that fraction now. So it would be 729 to 8. And question 2. Surface area of E to F, 4 to 49. So if we knew the surface area for every 4 of the smaller, we have 49 for the bigger. So scale factor for area would be 49 over 4. I'm going to leave as my fraction. So let's get a surface area scale factor for length. So I'm going to square root 49 over 4, which is 7 over 2. So when we're asked for the diameter of E to the diameter of F, it is a length. Diameter is a length. So it would be 2 to 7. And then part B, we need a scale factor for volume. Let's cube our scale factor for length. Give us 343 over 8. So the ratio would be 8 to 343. Okay, have a go at these 4 exam questions. Put me on pause and pause when you're done. Okay, for question 1, we've got 2 solid shapes, A and B, are mathematically similar. The base of shape A is a circle with radius 4, base of shape B is a circle with radius 8. So already I'm thinking, well, I can find the scale factor for length because I've got 2 lengths. So 8 divided by 4, which is 2. The surface area of shape A is, just going to put area, I know this is surface area, it's 80. Work out the surface area of shape B. Well, to find the surface area, scale factor for area, I need to square the length to get 4. So times my 80 by 4, 320. The volume of shape B is 600 centimetres cubed. Find the volume of shape A. Well, I need a scale factor for volume. So I need to get my scale factor for length and cube it. So this time it's shape B. So I need to divide by my scale factor volume to get A. So 600 divided by 8. 75 centimetres cubed. 2 cylinders A and B are mathematically similar. Height of cylinder B is twice the height of cylinder A. So I'm going to put 1 and 2 because that's double. Total surface area of A is 180. Calculate the total surface area of cylinder B. So scale factor for length is just 2 divided by 1, which is 2. Let me square that to get a scale factor for area. 2 squared is 4. I need to multiply this by 4. 720. Okay, have a go at these next 4 questions. Put me on pause. Okay, question 3. Diagram represents a large cone of height 6 and a base diameter 18 centimetres. The large cone is made by placing a small cone of height 2 and base diameter on top of a frustum B. Calculate the volume of frustum B. Give your answer in terms of pi. Okay, so A is similar to the big cone, like the mixture of AB. Let me just draw, there's my cone A. And the big cone is like a direct enlargement of that small cone. Let's see, we know the diameter of cone A is 6, B is 18, so we can find a scale factor for length here. 18 over 6, 3. Okay, so the volume of a cone you can get from the formula book is 1/3 pi r squared h. Let's get the volume of this small cone A. So the volume of cone A is 1/3 times pi times, well, your diameter is 6, so your radius is 3. 3 squared times 2. We want it in terms of pi, so 3 squared times 2 times 1/3 is 6 pi. We've got the scale factor for length. Let's cube the scale factor for length to get the scale factor for volume. 27. And so volume of the big cube, no cone, the big cone, I'm just going to call it A plus B, would be 6 pi times 27. is 162 pi. So to find just the frustum, just the B, it'd be the big cone volume minus the small cone, which would be 156 pi. Okay, question 4. Cylinder A and cylinder B are mathematically similar. The length of cylinder A is 4 centimetres, length of cylinder B is 6 centimetres. So I'm just going to find a scale factor for length. Which is 1.5. The volume of cylinder A is 80 centimetres cubed. Calculate the volume of cylinder B. So scale factor for volume is 1.5 cubed. Which is 3.375. We're going from the small cylinder to the big cylinder. So 80 times 3.375, 270 is your volume of cylinder B. Okay, just to finish off, have a look at questions 5, 6 and 7. Okay, question 5. X and Y are two geometrically similar solid shapes. Total surface area of X is 450 and Y is 800. So let's find the scale factor for area. (16/9). We've got the volume of shape X. We want to find the volume of shape Y. So we need a scale factor for length. Square root 16/9 and we get 4/3. So the scale factor for volume would be 4/3 cubed, which would be 64/27. So we've got the volume of the smaller shape, so we need to times that by the scale factor of volume to get to the volume of the larger shape. 3,200. Okay, next question, question 6. Got two mathematically similar shapes. Total surface area of P is 90 pi. Total surface area of Q is 810 pi. The length of the cylinder P is 4 centimetres. Work out the length for Q. So let's find a scale factor for area. 810 pi over 90 pi, which simplifies to the pi's cancel because pi divided by pi is 1. So that simplifies to 9. So the scale factor for area is 9. Scale factor for length is square root 9, 3. Length of P is 4. So if we times that by our scale factor for length, which is 3, we get 12 centimetres. And we're given the volume of P is 100 pi. Work out the volume of Q in terms of pi. We want a scale factor for volume. So let's cube our scale factor for length. 27. So 100 pi times 27, 2,700 pi. Okay, last question. Two cones are mathematically similar. Total surface area of P is 24. Total surface area of Q is 96. So let's find a scale factor for area. Four. Scale factor for length. This is square root of 4. which is 2. So the height for P is 4. Let's multiply it by the scale factor for length, which is 2, which gives you an answer of 8. What a scale factor for volume for the next part. So we're going to cube the 2. We need to cube the scale factor for length, which is 8. So the volume of P is 12, but let's times that by 8 to get the volume of Q, 96.